Section 6.5, trigonometric equations. Alright, so what we're going to be looking at here is solving equations that have trigonometry in them, basically, okay? We're going to be looking at solving for x, solving for the argument here. So let's look at sine of x is equal to 1/2. What are we looking for? We're looking for the value of x, and whenever I take the sine of it, it gives me 1/2. Now let's think about this for a second. If I think about my unit circle, here's my unit circle. Where do I have sine values? Which angles? Give me sine values in 1/2. Well, wouldn't that be at pi over 6? Remember, the sine is the second number in order pair, right? So that at pi over 6. And where else? Which other angle do I have a sine that is 1/2? Well, that would be over here at the reference angle of pi over 6. And I would add the second number there, 1/2, right? Alright, so what is x going to be equal to? X is the angle whose sine is 1/2. Well, that angle could be pi over 6. Pi over 6. And that angle could be this. Could be this angle right here. Now, what is that angle? That angle is pi back off pi over 6, right? The angle would be pi minus pi over 6. Or we could say 5 pi over 6. So x would be equal to 5 pi over 6. Now, somebody might be thinking, what about if I start at pi over 6 and I go around 2 pi more radians? Well, I'm back again at a sine that is 1/2, right? Like this says. Same thing here. What if I start here? I have a sine that's 1/2. But if I go all the way around 2 pi more, I'm back where I have a sine value of 1/2. So I need to consider every time I rotate around 2 pi radians. And like I said, every time. So times n. Same thing here. Plus 2 pi n, where n is an integer. Where n is an integer. What does that mean? That means n runs through 1, 2, 3, 4, 5, -1, -2, -3, and so forth. And n takes on a value of 0. But n doesn't take on fractions or decimals or whatever, okay? So the way this book writes a solution set is they say, okay, my solution set is the set of x's such that x is equal to pi over 6 plus 2 pi n, and x is equal to 5 pi over 6 plus 2 pi n. And they put it like that. I like to add something to this. I like to say where n is an integer. Go ahead and get in the habit of putting where n is an integer, because your teacher next semester will probably take off if you do not put that, okay? So let's get in the habit of doing it now, form a good habit now so we don't have to suffer for it later with points off. Okay, good. Everything's still recording. I'm letting you stand today, and I just did this whole lecture and it did not record, so this is the second go around. Let's see. So that's why you're going to see me going to the back of the camera today. Our next example, solve 3 square roots of 2 plus 6 cosine of x is equal to 0. And part A says over the interval, let me go ahead and put over interval from 0 to 2 pi. And then part B says what? Over set of real numbers. And what they mean by that is they mean all real numbers, okay? So let's take a look at this part. 3 square roots of 2 plus 6 cosine of x is equal to 0. And let's look at solving for x. So I'm going to go ahead and subtract this from both sides, and I get 6 cosine of x is equal to -3 square roots of 2. And negative, we'll divide both sides by 6. We get cosine of x is equal to negative 3 square roots of 2 over 6. Or we can say cosine of x is equal to negative square root of 2 over 2. So what are we looking for here? We're looking for the angles that whenever we take the cosine of them, we get negative square root of 2 over 2. Let's think about our old trusty unit circle here. Let's see, first of all, where is the cosine going to be a negative on the unit circle? Quadrant 2 and quadrant 3, right? And where do I have square root of 2 over 2 for my first value? Or negative square root of 2 over 2 for my first value? At a reference angle of pi over 4 here. And then over here I get negative square root of 2 over 2 as my first value. At a reference angle of pi over 4 here. Alright, so which angles is this? One of them is going to be what? One of the angles is going to be this angle right here. Or couldn't I say that that is pi minus pi over 4? Pi minus pi over 4? What's pi minus pi over 4? Yeah, 3 pi over 4. So 3 pi over 4 is this angle here. So I'm going to list 3 pi over 4 there. Okay? How about that other angle? The angle that goes from here to here. Well, wouldn't that be pi plus pi over 4 more? Pi plus pi over 4 more? What does that give me? 5 pi over 4? So I'm going to put 5 pi over 4. Now let me go ahead and put in this just to get us in the habit of this now, okay? Let me go ahead and put plus 2 pi n plus 2 pi n here. Okay? And what we're going to do is we're going to take a look at what about when n is 0? What about when n is 1? What about when n is 2 and so forth, okay? How about when n is equal to 0? If n is equal to 0 here in here, 0 times 2 pi is 0, plus 3 pi over 4 is 3 pi over 4. When n is 0 here, all this zeros out, I'm left with 5 pi over 4, right? How about when n is equal to 1? What about when n is equal to 1? I have what? 2 pi here. 3 pi over 4 plus 2 pi. Well, what does that give me? That gives me something that's too large, right? If I only go what? From 0 to 2 pi, if I start out with 3 pi over 4 and add 2 pi to it, that's too large. Same thing here, right? If n is 1, then I'm going to add 2 pi to 5 pi over 4. Well, that gets me way outside of this interval right here. So I'm going to put too large here. Too large. Alright, so what is my solution set over the interval from 0 to 2 pi? My solution set's going to look like this. X is equal to 3 pi over 4. And actually, they don't put x is equal to in this solution set. They just put 3 pi over 4 and 5 pi over 4. That's all the answers to this on this interval from 0 to 2 pi. Now what about over the set of all real numbers? That's when this part comes in. So I'm going to say over the set of all real numbers, my solution set's going to be x such that x is equal to 3 pi over 4, 3 pi over 4, plus 2 pi n, and x is equal to 5 pi over 4, plus 2 pi n. And let's put where n is an integer. where n is an integer. All right, so what are we saying? We're saying over the interval from 0 to 2 pi, you'll have a certain number of solutions here, okay? But over the set of all real numbers, that's where this plus 2 pi n is going to come in. Now, why am I picking plus 2 pi to add? The whole reason I'm picking plus 2 pi to add is because we're looking at cosine, and the period of the cosine is 2 pi. So if I were to have tangent and cotangent here, what I would put is plus pi n, since the period of those is pi.